Thank you for coming to Java 1. I am Jitendra. I will be talking about JSR 353, a new JSR. It's about Java API for JSON processing. It's actually safe harbor statement, somehow it got lost. So briefly, the program agenda is we'll talk a little bit about JSON and its overview. I'm sure most of you are familiar with JSON, but we'll just spend briefly few minutes. And some of the use cases, especially from the enterprise side, JAX-RS use case. Then we'll see the standardization process about this particular JSR 353. And we'll spend more time in the API since we have editors draft out and we have the API. So we'll spend more time in the API, and if there is some time, we'll see some demos. So what is JSON? JSON is basically a lightweight data exchange format. It's basically a textual representation on the wire, and it's very easy for humans and machines to read and write. It's very compact. Since it's part of JavaScript, it's basically a de facto standard between browser and server communications. It's used increasingly in many of the use cases like RESTful web services or in databases, for example, or even in configuration. Traditionally, XML has been the strength of configuration, etc. So, for example, if you take a small JSON text here, it's basically a person's representation. This person representation has three name value pairs. Here this JSON is basically an object structure which has three name value pairs. The name contains a string value, that's Bob, and the age has a number value, and phone is once again a array structure which contains two phone numbers. So basically JSON has two top level structures, which is like object structure as well as array structure. So other day I was looking at many of the developer APIs offered by many of the popular websites. Most of these RESTful web services, they offer JSON. As you could see, like I went through some of the sites and I myself was looking at their developer APIs. Most of them offer in JSON. And in fact, some of these popular web services, they offer basically they discontinued support for XML. So, for example, I was looking at the Cloud Search API here. If one uses Amazon's Cloud Search and searches for Star Wars, you basically get a JSON document where it says that the number of hits for the JSON document, JSON is like 7 documents, and the hits contain the documents which contain the Star Wars label. Similarly, let's say if someone uses the Twitter search, and if you search for JSON, you get a JSON tag itself. Basically, you get output in JSON, and it has bunch of tweets. So I have a brief demo basically parsing this Twitter search API. So since we are talking about RESTful web services in the platform, the standard to do RESTful web services is JAX-RS. In this example, for example, let's see how the XML is being used in the RESTful web services using JAX-RS. Let's say someone creates a RESTful endpoint and calls, basically it has a get book, may be called for the HTTP get method. So in this case, the application is returning a source object, which is part of the JAX-P API. Since JAX-P XML has good support in the platform, and JAX-RS runtime takes these source objects and converts into the textual representation. So on the other hand, let's say the endpoint basically returns a book object, and the book object could be converted to the textual representation using JAX-P API. That's also part of the platform. So we have very good support for XML overall in the Java platform. Let's say the same application, traditionally like any RESTful web service, basically you want to represent it in multiple representations. let's say if the client asks for like a XML representation, it should be given in XML, or if the client asks for JSON representation, it will be given in JSON representation. So that's basically the core principle of any RESTful web service. In this case, let's say JAX-RS resource basically gives a book object, and based on the HTTP headers, accept header, so the JAX-RS runtime decides whether to give the XML representation or whether to give the JSON representation. So again, for XML, it can use a standard API in the platform, which is JAX-B. For JSON, like many of the JAX-RS itself doesn't support JSON, but many of the JAX-RS implementations, they support JSON. So as you could see, like there are many Java implementations for JSON, like many libraries, like some of them are very popular, like for example arg.json, the reference implementation for JSON itself, and Jackson, Google JSON. Some of them do the binding from the objects to the representation, and some of them just do the processing. So we have many implementations. So the way most of the JAX-RS implementations implement JSON basically is JAX-RS has this pluggable mechanism to convert a textual representation from particular object. So that's basically message body reader and message body writer. So you can plug in your own message body reader or writer. Let's say take an example like for example, if the object is JSON object, which could be converted into JSON using JSON Aux API. Or if you have an object like a book object that could be converted into XML, and that XML could be converted into JSON. Like there are some libraries which do this, like Jettison, etc. Or there are some libraries which directly take the POJO, the book object, and directly converts to JSON. For example, Jackson, Eclipse Link. There are quite a few APIs which do that. But the problem is like since many of the JAX-RS implementations themselves support, so sometimes the applications themselves, they don't bundle these particular libraries on which this binding or the processing is involved. So if you move the application across the application servers, different vendor implementations, they fail. Actually, we see some of the messages on our users mailing list about this. And some of these solutions also have technical limitations. For example, it doesn't naturally map from XML to JSON, since XML has the namespaces and many additional constructs. Those things directly don't map to JSON. So you typically end up having some technical limitation. And the other thing is applications themselves, they have to bundle these libraries if you want to be portable across application servers. And that also causes sometimes problems because the application server itself bundles some of these libraries. So the advantage of being a standard API is like the applications use the standard types, and applications don't have to bundle these libraries. So the applications become portable across application servers, as well as they will become very linear. So what we thought of doing is basically like two JSRs. One is for processing of JSON. It's much similar to what is there in XML world, that is JAX-B. The other important use case, definitely, which we are not ignoring, basically JSON text to Java objects binding, because that's a very important use case as far as JAX-RS is concerned, because we want to create multiple representations out of a single POJO. So that is much similar to JAX-B. So that's what we've been thinking about doing two JSRs in the same lines of JAX-B and JAX-B. So the first one which we are doing is basically Java API for processing JSON. It's just a pure processing, similar to what JAX-B has been providing. So here we are considering two APIs. One is a streaming API to produce and consume, basically reading the JSON in a streaming fashion and writing JSON in a streaming fashion. It's much similar to the Stacks API. I think it's very popular, the Stacks API, and it's a bit low level, but many of the applications are written in Stacks. In fact, as far as the infrastructure is concerned, it's very useful. Like you could see that many of the SOAP stacks are implemented on top of the streaming API. So we expect that the similar kind of benefits we achieve using providing an API for JSON. On the other hand, we will have a little bit higher level API like object model API. It's similar to the DOM API in XML, but it will have much more nicer constructs using the latest Java constructs. So that's high level for this particular JSR, the contents of this particular JSR. And we have 3 corporate members in the expert group and 3 individual members, but we also get quite a good contributions from the user community. So in fact, couple of users are quite good, and for some reason they couldn't be there in expert group, but nevertheless they contribute to the specification. So currently JSR 353 has gone through the early draft review. I think within a couple of days the early draft review ends. The next major milestone is the public review. By that time we want to incorporate all the feedback into the public review and close most of the issues except only blocking issues by the proposed final draft. The rest of the states like ballot and all, these are primarily the processing stages. So this particular JSR is also done in JCP 2.8. So that means we have some strict transparency guidelines, and we are following those transparency guidelines. This particular specification itself is done as an open source project, and we have created 2 mailing lists. One is the users mailing list and the other is the expert group mailing list. And the expert group mailing list, whatever the communication happens on the expert group mailing list, that is JSR 353 experts, that will be automatically reflected on the users mailing list. So you could see all the communication among the experts you would see on the users mailing list. The only thing is any user cannot directly write to the expert group mailing list, but you could see all the communication. In fact, whatever issues or anything you could raise on public issue tracker, so that's quite open. Anybody can, any Java.NET member can post any issue or what you would like to see in the JSR API. And all these mailing lists are also publicly archivable, so you can take a publicly archived, so you can take a look at it and you can become a part of the project itself. So the schedule, what we thought initially was like we would like to start basically both the JSRs, but the first one is JSR 353 has started, which we are planning to put it in Java E7, and the binding JSR will go in the next Java E release. So it's aligned with Java E7 schedule, which is the expected schedule date is basically the spring of 2013. So as far as RI is concerned, RI is also basically done as an open source project under basically under Glassfish umbrella, and it's pretty much up to date with respect to spec, except I think auto detecting the encoding from the input stream. All the latest bits also in the Maven Central, so you could always you can try it and give a feedback, so that all the feedback will be incorporated before the public review. Okay, so as I said that I will spend more time in the API. So before going to the API, I'll just briefly talk about the grammar, so that once we talk about the abstractions, we will have a clear picture like how the grammar and how the API is going to be related. So JSON has primarily 2 structures. One is the array structure and the other is the object structure. So the array structure is basically starts with square brackets, and it will have 0 or more values. So as you could see in the first first railroad diagram. The second high level structure basically JSON has is one object structure. It starts with the curly brace and ends with the curly brace, and it has basically 0 or more name value pairs. The name is a string, and value could be any of these particular values. So there are 7 value types, primarily the string, number, and once again you can nest the main object structures like object structure and array structure, as well as 3 literal values, true, false, and null. Okay. So as I said that basically this API consists of 2 top level APIs. One is a streaming API and other is the object level API. The way we see that, like, a streaming API is a very low level API, very efficient to parse and generate JSON. It doesn't create any intermediate objects. It could be used for applications as well as any infrastructures, like let's say if someone is doing a binding framework, so they could use on top of this particular API. And here we also provide a pluggability for both parsers and generators, so that if any vendor or if any other implementation wants to provide their own parser and generator, which is more efficient than the default implementation, that could always be loaded using a provider. On the other hand, Object Model API is a very simple API. It's a high-level API, and it has a very few abstractions. And moreover, all the API basically, when you take a look at it, I think you should able to start programming within an hour, basically. So that's basically the aim of API. The abstractions should be very self-evident. So you should be able to code pretty fast. So let's see the basic architecture of the API, how it is. So underneath, basically, we have a SPI using a. So we have the SPI to plug in basically the parser and generator. So any provider could basically provide parser and generator. The parser and generator will be loaded using the standard service loader mechanism in Java SE. And then on the top of it, we have the streaming API. Streaming API is nothing but a parser and generator. So the Object Model API sits on top of the streaming API. It uses whatever the parser and generator available from the provider, and it builds the higher level objects. Sometimes Object Level Model API is also called the tree API, because it's basically object level structure in a tree format. Then on top of it, basically you have the applications. The applications could be using Object Model API, or it could be using the streaming API. So it's based on the needs of the application. So let's take a look at the first abstraction in the streaming API, that is the JSON parser. JSON parsers primarily, as the name suggests, it parses JSON, but it parses JSON in such a fashion that it parses JSON in a streaming fashion. It's much similar to Stack's XML stream reader. So those of you know about Stacks, it's basically a pull parser. It's basically forward only parser. So you cannot go back. So you keep parsing the JSON, and when you reach certain state in the parser, you could directly get whatever the data you require using the necessary methods at that particular state. So other thing is like created a very easy static factory to create these parser objects. Like we have like JSON.create parser, and you can you can give a stream, and it will create a JSON parser object. Similarly, we provided a parser factory also, because if you see the JSON.create parser, for every call it basically takes because it's trying to find a provider, so it is incurring basically a service lookup cost. So that's why we created a parser factory, so that once you basically create a factory, you could use the factory to create multiple parser objects. But the main thing which you have to deal with is only the parser abstraction. A parser also could be configured with any feature, like any parsing behavior you want to incorporate during the parsing process. You could always create with certain features. Let's say if a particular implementation want to parse JSON using single quoted strings. Typically JSON strings are double quoted strings, but let's say if a parser implementation wants to parse using a single quoted strings, basically they could provide a feature, and if the parser understands that feature, they could always pass that particular kind of JSON. But the spec itself doesn't provide any non-standard features, but if an implementation wants to do it, they can always do that. So there are a bunch of parser state events. I will go through them. Like for the starting of array and starting of object, there are basically start array and start object. Similarly, for the end of parsing state for end object and end array, there are there, and rest of them are primarily the value states. So let's take a look at some of this. Like for example, I have a JSON parser. JSON text. So how the parser will be giving is at the start of the curly brace, you will get a start object event. Similarly, at the first name, basically that's a name value pair. So at that time you will get the key name, and you could always get using a get string at that particular state. You can always get what is the name of that name value pair. Once you advance the parser to, let's say, to John, for example, so you will get a value string because it's a it's a JSON string value. So at that time, if the parser wants, it can always get the value of John. Similarly, let's say at the end of number 25, you will get the value number parser event, and you could use a necessary method to get the parser value 25. Similarly, at the start of array, you get a start array. So that's a typical behavior. So you advance the parsers to a arrange state and get the necessary data. Yes, please.
So you said that was a forward streaming.
Right.
When you hit start array, you already passed phone number. Even though that phone number was associated with that start array.
Basically, all it's saying is when you are at the start array, basically it is giving a start array this one, but phone number you have to keep some state saying that this is a phone number, and all you get is phone number is basically it's a name value pair here. As you could see, phone number is just a name, and the value just turns out to be the array, right? Yes, yes, definitely, because it's a key name, right? So every key you have a basically key name state will be associated. Yeah.
With a value that's a string, is it possible to read it as a reader, so that if it's, for example, a base 64 encoded movie,
Mm-hmm.
it takes many megabytes,
Right.
you'll be able to process that without bringing in a single object, single string?
So at present in the parser API we just have a string. So but in the object API I think we have a little bit of abstraction. But so yeah, that's the kind of feedback which we are kind of looking whether we could always add additional methods on the parser because at any state you can get the data in different formats, especially for the number. So you could get, for example, the number 25 as an int value, or the number 25 as a long value, or it could be any other, because here it's all textual representation. So we could add pretty much any method basically we want. Right. So let me go ahead, and at the end of the array you will basically get the end of array start event. So for example, if you want to get the value of John, you advance the parser to the start object. So you basically get to the start object, right? You get to the start object, then you advance the cursor to the key name, then you advance to the value string, and then at that time you call parser.getString, you get basically the John value, right? Those of you are familiar with stacks, I think it feels very natural. Basically, you moving the parser in a streaming fashion and get the necessary data. The only disadvantage of this low-level API is basically at certain state you might, let's say at the value string state, for example here you might call I want to get this as a number, for example. That will throw an exception. It's not type safe in that aspect, but it doesn't create any intermediate object. It doesn't create you are directly taking whatever the information available in the parser buffer and directly giving that information whatever the user wants it. It doesn't create any unnecessary intermediate object. It doesn't convert anything. It just gives whatever the user wants. That's why it's a bit low-level API, but it's very highly efficient API. Okay. So other abstraction in the low-level API is JSON generator. So the JSON generator is primarily generates JSON in a streaming fashion. So it's much similar to Stack's XML stream writer. So you can keep writing JSON in a streaming fashion to whatever the stream output source it's available. So like parser, it's also created using a static factory JSON.create generator, or you could create a factory and the factory could be basically create the generator. So what happens here is in future probably the factory could also be injected basically into EE environment perhaps, but it's not there right now in the spec. But in future probably the parser factory could be injected into the any EE component. So optionally a generator also could be configured with the pretty printing or any other feature. For example, if a provider basically creates any feature, so that feature could be used to configure the generator object. So for example, one is the pretty printing is one of the common features. Like you want to write generating the JSON basically in a pretty format. So here we also allow method chaining, and it's pretty type safe. I'll show with one example here. So as you could see, like it uses basically something like a kind of a chained method, like object add, end object, begin object, etc. And whatever is the way you are generating the JSON, that reflects whatever is generated on the output. So it's exactly the similar kind of structure, like begin array will write. So as you could see the same structure which you can use it in the code. And the advantage here is like it's also very type safe. So in the object, all they take is basically two name values. That means two parameters will be used in all the methods. But if you want to write a single value, it doesn't allow, because we made sure that you cannot mix and match object methods and array methods. So that's what I mean by the type safetiness. So that type safetiness works for multiple nesting levels also. So while showing the demo, probably I'll take a look at it and I'll show some of the code, how that works. We just use some generics tricks basically to make sure that it's very type safe. In the IDE and all, while filling it up, if the scope is basically object, it just allows only the object methods. If the scope is array, it allows just only the array methods. So that's all we have in the streaming API. Then we'll come to basically the higher level API, which is the object model API. So here also we have basically very few core abstractions. One is the JSON object and JSON array, which are basically the tree structures for the JSON object and JSON array. Then you have a builder which can build the JSON object and JSON array from the scratch. Then you have a reader and then you have a writer. The reader basically creates JSON object and JSON array directly from the input source. And the JSON writer writes JSON object and the JSON array to the output source. This is much similar to like when you are serializing objects using object serializer, object input stream and object output stream. It's much similar to that. Basically, you are reading object directly from the reader, and similarly the writer writes the JSON object and JSON array to the stream. So in the object and array, we also have a little bit of wrapper types for JSON string and JSON number. So that's one place I think we also need a feedback. So instead of directly mapping to the string and directly mapping to, let's say, any primitive type or like a primitive type int long, or for example, or a big decimal or big integer, we created a JSON number wrapper type. So that's one place definitely we need some kind of feedback once after using. Please let us know whether that is working out okay or not. So the advantage here is like JSON string and all. A string could be represented basically like, for example, based on the file system. Like the string could be somewhere hidden in the file system, but while writing, we could basically take from the file system and just dump it, rather than just mapping to the string. Similarly, for the number, what could be the number type, for example, integer, long, or whether it's a big decimal, or so some of the other methods are there in this one. So that's why we provided at present the wrapper types. So, but if we want to provide, let's say, directly the primitive types, probably, yeah, we can take a look at it once again. So let's see, like, what is the JSON object? JSON object primarily holds name value pairs, and we also decided that we'll make these objects immutable, so that we could use probably with lambdas, or we could basically in concurrent systems, it's much easy to manage basically the immutable objects. So that's why we created this JSON object and JSON array as immutable objects. And if you want to access the values, you could always access as a map string and map of string and JSON value. But even the return map is basically unmodifiable map. So it's basically a immutable structure. So for example, JSON object, let's say somehow you create a JSON object via JSON builder or JSON reader, and you can get the values using a map. So object.getValues gives the map. Yeah.
Is the iterator guaranteed to return in the same order as the properties appeared in the document?
Yeah, so the iterating order, we defined the way you construct the JSON object. So that's clearly defined. So because otherwise it's a map, right? So you could be getting the name values could be any order. So but the iterating order we defined in the spec to be the way you build the JSON object or the way you build the JSON array anyway, it doesn't have any problem, but object, yeah, we definitely define the iterating order. So on the other hand, it also has a little bit top level accessor methods, like from directly from the JSON object you can get a JSON number. From the JSON number you can get like it has methods like you can get the int value or you can get the int value exact. Like for example, one basically truncates if the number doesn't fit. If the number fits, so for the other one basically JSON I think int value exact, I think it throws an exception if the number doesn't really fit into integer. So it's just like whatever the big decimal has, the int value and int value exact, it's kind of similar to that. So like that JSON number, we have a little bit wrapper type, but we may add a couple of methods by which you can, especially the int value, probably we will directly add to the JSON object. You can directly get the int value without going to the JSON number. Similarly, we have a way to access the names using basically, let's say if you want to get all the names, you could get using the names in this particular object. Take a look at that and see if you require any new methods. Yes, please.
Speaking about like this object model, what would be your strategy to tell in dates and replacing dates back and forth to JSON from JSON?
Dates?
Dates, yeah, Java with the dates.
In
Or Java with till timestamp.
Yeah, JSON itself doesn't have any concept of date. I think that's part of JavaScript, I believe. JSON basically, as you could see in the whatever the grammar I showed, it doesn't have any concept of date. So it's up to you how you want to represent date, either in the string format, or if you want to represent maybe a long milliseconds or something. It's up to the application. There is no support as such in the API itself. Yeah. Okay. Then the JSON array. JSON array is basically a list of values, and here JSON array is also immutable. Similar to JSON object, here you can access the values using a list JSON value, basically the standard collections library. For example, let's see. So you could get the get values using as a list, and you can use any of the collection APIs, or tomorrow if the Lambda comes up with streaming APIs, etc., you could be using all of those things on top of this. Similar to whatever JSON object you have seen, you can get a JSON number or JSON string, and you can access the necessary data. Okay, so let's take a look at the next JSON builder abstraction. It just follows a builder pattern. It builds JSON object and JSON array from scratch. So using a builder pattern, it allows method chaining similar to what you have seen in the JSON generator. Once again, it's a type safe. You cannot mix and match array and object methods. So let's say if you want to create, let's say, a empty JSON object, you create a new JSON builder. You start a begin object. You basically end the object, and you say build. You have that JSON object. Yes, please.
Is there a way when you begin your building, is there a way to determine whether or not you can build an array or an object?
While building you cannot, but while reading and writing we do have. While building you typically know whether you are building a object or whether you are building an array, right? While writing you don't know, like in some cases it's just a JSON structure. You know whether it may be a JSON array or JSON object. We could just write it. You don't have to write it. You don't have to use a specific method. So, but while building, I think you typically know whether you are building a JSON object or JSON array. So that's why there are two calls, basically begin object or begin array. So that's the approach so far we have taken. So otherwise, how do you build a? So let's say if the JSON is there in the, let's say in the text file or something, or in a file system, there you don't really require to know whether in the text file whether it's a JSON object or JSON array. That you can read it. But while builder, I think you typically know whether you are building an object or array.
You have to know if what's in the text file is an object or an array before you determine, okay, I'm building an object.
So while building from the text, we have a JSON reader. I think you will see that actually. So there you can directly, you can just read from the text file, and the parser will figure it out, and it will create appropriate structure for you. Yes, please.
Does the JSON object override the toString methods so that it'll actually output the JSON object?
At present, we haven't specified that in the API. Whether so, yeah, maybe implementations probably will do, but at present we haven't really specified that semantics in the API as such. Yeah. So you are asking about the question. Yeah, the question is, are we specifying about the toString in JSON object and JSON array? So if you take a look at the JSON builder, it's similar to what JSON generator has done. In fact, they share the same core abstractions. So once again, the object which you are creating for that particular JSON, they resemble exactly similar API structure, similar structure. The way you are generating, let's say, type within an object, that's how you basically begin an object and you add that particular name value pair. So that's how, and it's a builder pattern. So once you build, you have a JSON array. Yes.
In JSON, you just call one function. You give an object. In Java, you say JSON.
Right.
Why would you need
So that is basically POJO to JSON binding. So that will happen probably in the next JSR, which we are talking at the binding JSR.
So this is just mid-level?
Yeah, it's actually a bit low level, and if people who don't want to use instead of dealing with the POJOs, if you want to directly build using ground up from the scratch or from the object from the file system, you want to directly read it, that kind of a processing.
Yeah, it sounds like this is more finessing the data,
Mm-hmm.
this assumes an awful lot of responsibility at this level.
Mm-hmm.
Where this other one that he's talking about,
Yeah.
you throw the responsibility back to the caller.
Mm-hmm.
You
No.
don't have to necessarily be all that intelligent about it.
Yeah.
The caller needs to be.
There also we need to know exactly, let's say you have a POJO, when you are serializing it, you need to know exactly how to bind certain things. If there is a cyclical structure, if it is an interface, there are so many things in the binding here, or if there is a list, for example, any collections, you need to have some standard thing to how to map this to JSON.
Right.
But most of the implementations, they do.
Just throw errors for that stuff. Let the user take responsibility for it.
No, if you define what exactly the binding is supposed to take care, what all the Java's like semantics for all the Java's structures, like for example, generics or collections. So that's what is involved when we do the binding specification. That's what we are going to do that. Okay.
In that previous slide, I probably just don't see it as the example here, but
Mm-hmm.
there's a way in the API to do a name value pair where the value is an object or an array.
Yeah.
Of course, right?
Yes.
Okay.
Yes, it's
Are
there.
those method signatures different? Than
No, it's the same. Like
the adds here?
no, it's the same. Basically, the add would take, let's say, type, and if you already have a JSON object, you can just pass it as a second argument.
And
Similarly.
so obviously we're doing a build here. If you don't have a JSON object,
Okay.
can you start creating a nested object here, or do you have to have already created?
If you are building from scratch, you have to basically nest it. If you are building from scratch, but if you already have a JSON object and you want to put that into a new JSON object, you can always do that. So if you take a look at that add methods, basically it's just not a string and integers, but it also has basically you can put complete the nested JSON, any other tree, basically JSON object or JSON array, you can directly attach it. So the other abstraction which we have is the JSON reader. JSON reader is basically, instead of building from scratch the JSON object and JSON array, you are directly using a file. If the text is available in some stream, you are basically converting that stream into the JSON object and JSON array. So you could also use the ARM blocks so that you don't have to explicitly close the readers, but it's very straightforward. Just like reader.read object, you will get a JSON object. Reader.read array, you will get a JSON array. So if you don't know whether it's a object or if it is an array, you can just call reader.read. It will give a super type of JSON object and JSON array. Here basically you are reading from the input stream or a reader. although if the input stream we automatically specify to detect the encoding, especially for the Unicode. But if the stream is not a Unicode stream, you could also optionally specify an encoder, or you can create yourself a reader and pass that to while creating the JSON reader. So once again, here the JSON reader could also be configured with the features. And since we said that JSON reader is built on top of the low-level API, the JSON parser, so it will always use the pluggable JSON parser. If any provider, yeah.
Back to his question from earlier,
Yeah.
where you get a file, you don't know exactly if the
Sure.
file is an object or an array.
Yeah.
So we plug it into a reader and let the reader determine what
Sure.
it is.
Yeah.
How do I know what I'm supposed to read out of it?
Yeah. You just say reader.read. There is one more method called read. Instead of read object and read array, there is a read method is there. That one will give you a super type of JSON object in JSON array, which is a JSON structure. So then you right. Yeah, then you can take a look at it and see what object it has read. Yeah. So similarly, the writer. So we have a JSON object and JSON array. So you could basically write these objects, JSON object and JSON array, to the output stream, or you could write it to the a writer. So by default, if you don't give encoding, it will write into UTF-8. Or if you could specifically create a writer with certain encoding, and you can ask JSON to be written in that particular encoding. Optionally, you can also configure with the features. Like let's say if you want to write JSON in a pretty format, you can create a feature for the pretty format and a pretty feature, and just pass it while creating basically the JSON writer. So once again, this also uses a pluggable JSON generator underneath. So if a provider provides their own generator which may be efficient, it will be automatically picked up, and the JSON writer, while generating it, it will use that generator and just writes it. So but the thing to note is basically just a couple of lines of code to write any JSON object, and you can wrap it in the ARM blocks. Yes, please.
About the pretty print, is there any ways to like configure your prettiness of
Yeah.
JSON?
Yeah, at present we haven't defined the prettiness, like it's up to the implementation, because I don't know like how exactly to define, like everybody can have different ways of doing the prettiness.
Yeah.
So there is no,
Is there any way to configure, like pass some kind of configuration for prettiness, like use the tabs instead of spaces, or
not in the specification as such. We just have for some features probably it will have that kind of data, but in prettiness we haven't. We just said it's a pretty, so it's up to the implementation to basically to format the way it wants to format it. So okay, then finally the configuration. So the configuration is primarily like basically it's a parser and generator features. It's basically a list of parser and generator features. So the spec probably will define only few features, and the implementations may add additional features as they see. But it also supports, as I said, it also supports extensibility. Like you can build the custom features, and once you build the features, basically you can create a configuration, and you can pass that configuration while creating a writer or creating a parser, etc. And if any implementation, let's say you are moving your code from one implementation, so let's say other implementation, and other implementation doesn't understand that configuration, it must throw an exception. So that will guarantee that that particular parser and generator, they understand that configuration. So yes.
I know you must have what was
Pretty printing basically, while writing JSON, it shows in much nicer format. I'll show you one example, like tabs, for example, it indents properly, etc. So that's
Similar to the examples we've seen already.
right. Yeah. So in the previous examples, when I formatted JSON in indentation and all, so that's something like a pretty printing. Rather than putting everything in one particular one in one line, instead of that, it's writing in multiple lines and indenting properly. So we still have some work, primarily like we haven't defined equals hash code kind of mechanisms. And what happens in the round tripping, basically you have a text and you created these objects and once again converted to text, and from that text you created one more object, whether these two objects are supposed to be equal or not. So that kind of semantics we haven't defined. Especially that becomes tricky with the floating point numbers, because the way floating point numbers has to be written onto the text is quite a bit tricky. So also whether we really need to define this equals and hash code is also not. We need to have a discussion, because within one particular provider we don't really require to define it. But let's say you have two providers, I mean two complete different implementations, and you created one JSON object using one implementation and you created other JSON object using other implementation. Should they be equal or not? So that's the only case probably at present in the API we need to declare this equals and hash code. Otherwise within one implementation, it's just one implementation, whatever mechanism it provides, we can say that they can. You don't have to explicitly specify like hash code, what is the exact algorithm for the hash code. We have to specify that probably it's supposed to be equal, etc., but we don't have to exactly specify what is the hash code algorithm. Similarly, we need to take care of exception handling and a few other bugs which are filed on the issue tracker. So take a look at it, and since the artifacts are already there in the Maven Central, so you can experiment it and see whether the API is simple enough and fluid enough to use it. So I'll show some demos. Yes. Yeah. You can definitely take part of the tree and just using a builder, once again you can plug into, you can create one more object and you can plug it in. Right. Yes, you can take any part of the tree and just put it into the builder. Yes, it's always possible. So I'll briefly go over a couple of a simple JAX-RS application which I have built, because we are driving from the JAX-RS point of view. So I have a demo application. So it's nothing but a JAX-RS application. As you could see, it's importing application path, and it has three resources. One is a parser resource, other is a generator resource, and other is the object resource. I'll come to what the body writer is doing. So the parser resource is basically it's listening at the path /parser, and it will parse Twitter streams. I hope you can see. Basically, it parses Twitter search API. Basically, it opens a Twitter search API for actually Java 1, and it opens a stream and it creates the parser, and it basically writes certain elements. Basically, the Twitter parser, if you see the Twitter search, it returns a bunch of metadata. So in this example, all I am interested is in two values. One is the from user, what is the user handle, and what is the corresponding tweet he is using. So, and then he just prints it to the output stream as a text plain. So as you could see, this particular is just a text plain representation. So the way we, if you see the Twitter's JSON string, JSON output is like it has a from user, what is the user handle. It's very deep nested in somewhere in the JSON tree structure, and it has a text information basically. I think maybe I should reduce. Maybe this is better, I guess. So all it is doing is it is when the event is key name, and if the value is from user, it is advancing to its value and gets a corresponding parser string, and it prints that particular value, and once again it goes to the tweet and it gets the corresponding tweet and just prints it. So let me show, actually probably then you'll get a clear idea of what it's doing. So as far as the Twitter search, let's say if I have Java 1, so this is the format it gives. So bunch of metadata. Then in the results it gives basically from user and the corresponding text. right? So that's all. Those are the two informations we are pulling out from this particular parser. So the from user, it is much deeply nested somewhere within the results, and the corresponding text information. That's all we are trying to get this from this particular JAX-RS resource. So like that, bunch of tweets are there. So if I run this particular demo with parser, so as you could see, basically the user and the user and the corresponding tweet, and the user and the corresponding tweet. So that's all this JAX-RS resource is doing. Okay. So it's just a simple parser API, how to use the parser. So any questions on that? Yeah, it advances the cursor to the from user and advances the cursors to text and just gets the corresponding data. It's that simple, and it's writing the data to in a streaming fashion. So if the data is huge, 1 gigabyte or something, it doesn't matter. You just keep on parsing the things in a streaming fashion, and it's also writing in a streaming fashion here. Only thing is, it's writing as just a text plane, just writing to the text plane stream. So other thing which I have is the generator resource. I have a simple example. For example, all it is writing is for the HTTP output stream, you just keep writing this bunch of data in a streaming fashion. So as I said previously, in the add method, for example, if you want to add something, so it will just give only the name value pairs. It doesn't give any of the array methods. So that's what I said. Like, you cannot mix and match object methods and array methods. So that kind of type safetiness is built into the API. So as far as the resource is concerned, basically all it is doing is directly creating a JSON generator for the output stream, that is a HTTP output stream, and generating JSON to that particular output stream. So if you see this, this particular resource is the net generator. So this is what I call the pretty printing. But if you see the actual data which we sent, that is just like this. I installed a small plugin to show that in the pretty printing in the browser. So if I close this, yeah. So whatever JSON is generated, basically that is coming to the representation. So this is also streaming way to generate. So if you have data you are pulling from database or something, and you keep on writing the data to generation, you can generate it as much data as you want, because you are not storing anything inside the memory. Yeah.
Just to be clear, that minus sign that's showing up, that's part of your plugin, right?
Mm-hmm.
Collapses them.
Right. Yeah, there is a JSON view plugin. That's what I installed. So that's what it is showing. Otherwise, what we are sending is basically just like this. Similarly, the next example is exactly same. That is parser object resource. The only difference here is basically the user has created an object here, and he just giving to JAX-RS runtime, and JAX-RS runtime basically converting this JSON object to the stream. So it's exactly like similar to what you have seen in the JSON generator, but the only thing is here the user created a JSON object, and he is returning that JSON object. Right. So that's all he is doing. Like, you got a JSON object from somewhere else, and you want to basically write it or something. So that's what is happening. So here the responsibility is primarily the JAX-RS runtime is taking the responsibility and converting this JSON object to the stream. So the way we do is like we created the body writer similar to other implementations. So all it does is it basically creates a writer using output stream and writes that particular structure. JSON structure is nothing but a super type of JSON object and JSON array. So that's all it's doing. But the interesting thing is this particular now this message body writer is portable across any JAX-RS implementation, because it is using the standard API. Yeah, and moreover, the applications in future probably they don't have to write this one, because this will be shipped part of the application server itself. When you have a tighter integration between JAX-RS and JSON, so the body writers for this particular objects, they all will be shipped part of the application server. So you don't have to really write it. But at present, since we don't have tighter integration, but in the future, by the time the spec ships, I think it will be part of the application server itself. So you don't have to write in your resource. All you have to do is you just return whatever the object, JSON object or JSON array. The JAX-RS runtime will take care of serializing that. Similarly, while reading also, it will automatically take care. If you want to map, for example, let's say do post, and if the HTTP request contains a JSON, you could directly map to JSON object, and the JAX-RS runtime will automatically take it. The input stream parses it and creates basically JSON object. So yeah, that's exactly similar to, you don't see any difference here even if I say object. So it gives the same kind of output. I think that's all I have actually. So if you have any questions or any discussion, we can have it. Yeah.